Alright, let's go ahead and get started right into this. This is my first video recording ever, and I have not done this before, but I think I've practiced some tricks to make this streamlined. If I do it right, you won't even notice that I'm doing any tricks. But if we get started here, we're going to look at lesson 10.2, finding arc measures on page 649 to 653. If you take your books to 649, we'll take a moment there to get you there, and then we'll get started. Once you get there, you'll notice that the key terminology that we see in this particular unit is something called a central angle. Remember, you're continuing to take your notes for your notebook and get the best notes you can. A central angle of a circle is an angle whose vertex is the center of the circle. So we have a central angle, and so we've got this here. Central angle of a circle is an angle whose vertex is the center of the circle. So here we go. Here's our particular central angle, and we know that if you have a, practicing my eraser here, there it is. If you have a angle, remember angles in geometry is two rays that share a common point or common endpoint, and so we call that part the vertex. So over here, vertex O is given to us, and we've got A and we've got B, and so we would call this angle normally angle AOB, and we call this particular one a central angle because its vertex is at the center of the circle, and so that's what we're talking about in this particular lesson. So a central angle of a circle is an angle whose vertex is the center of the angle. So we're going to look at this one together here, a couple of little terminologies that you want to have. And so if the measure of that angle is less than 180 degrees, less than a straight angle, then the points that lie on the interior of that angle form a minor arc. And so this particular lesson had a title talking about arcs, and so we're learning more and more about what's called an arc. Just to make it simple, an arc is this red region here. It's this region here that goes around the circle, but also the region that goes all the way around at the top as well. And so an arc is just a portion of the outside of a circle. So if the measure of a central angle AOB is less than 180 degrees, this portion here, then the points that lie on the interior of the angle form a minor arc. And so this particular one, A and B, that particularly one there, forms the arc AB, and you'll notice that they use the notation arc AB. So you got your A, you've got your B, and then you kind of draw a little arc over top of them. And so that's all you're doing with that. The point that the points that I'm down here at the bottom, the points that do not lie on the minor arc AB form a major arc. And so any points that would be up here, and so I'm assuming you can see some of what I'm doing, but all of this around here would form the major arc. The difference between a major and minor is obviously size. Majors are bigger, minors would be smaller. And then it says here a semicircle is an arc with endpoints that are also the endpoints of the diameter. So in a situation like this, you would have something all the way up here where we have kind of our circle that's formed here. There's a point, and we would make our point all the way across here, okay, forming a central angle. We could call this one D and this one over here C, and so this particular angle is 180 degrees, and so this particular portion of the arc all the way up here is what we would call a semicircle. When we draw semicircles, normally we would draw a, let's see if I can get this eraser to go away, a circle, normal one. And so we could get ourselves a circle. I got to find that button on here. Again, a semicircle is just half a circle, so this region up here. And so the points that do not lie on that form a major arc, and so that's what I'm talking about. A semicircle is an arc with the endpoints that are also the endpoints of a diameter. So I'll take a moment, zoom out here, and let you get some of the notes. But the important terminology is here. You need to first of all know what a central angle is. It's an angle whose vertex is at the center. You also need to know what a major and minor arc would be. If it's smaller, if the arc is smaller than 180 degrees, maybe I should write that as well. So a major arc is going to be greater than 180 degrees, whereas a minor arc would be less than 180 degrees. And so That's what we're talking about. Now, a semicircle technically is equal to 180 degrees. And so as we learn some new terminology, that might be very helpful to you. Following down here and just kind of having some of the pictures that might be helpful, you'll note minor arcs are named by their endpoints. And so I'll see if I can get this straightened out for you. Minor arcs are named by their endpoints, while major arcs are named by their endpoints and a point on the arc. And so if we looked at particularly this circle, not looking at any of the other ones, but this top portion, if you can see where I'm pointing, let's see if I can use the mouse instead. But if I'm talking about this top portion of the circle here, you'll notice that's the major arc. Down here it's the minor arc. You'll notice over here at the semicircle we've got 180 degrees all the way around this, but at this also 180 degrees on the bottom, so 360 total. On this side, on the minor arc, you've got a smaller angle, and on the major arc you have a much larger angle. Obtuse, acute on this side. So you'll notice if we named the bottom arc, we would still call it, the minor arc would be AB. According to the rule, an arc. That's our notation. So it says at the top, minor arcs are named by their endpoints. And so our endpoints were A and B, so we call that minor arc AB. And then it says the major arcs are named by their endpoints and a point on the arc. And so at the very top, I couldn't just call the major arc AB because then I would confuse it with the other one. Rather, we would call this ACB. And again, that's kind of systematic as you go across this clockwise. You call each point. So we'd call that the major arc ACB. And so this is really how you can tell the difference between that one being major and this one being a minor arc. Okay, so that one's major, this one's minor. So again, that's an important concept. And as we start using terminology and names, you'll want to know the differences between those. All right, let's look at the key concept. All right, so this is the new thing that we need to know for this particular lesson. Looking at this particular one, it says measuring arcs. The measure of a minor arc, or how big it is the measure of the central angle. So if you want to know how big this minor arc is, look at that measure angle. The measure of AB, or arc AB, is 50 degrees. Well, we don't need to look any further than the measure of the angle. So it says over here, the measure of a minor arc is the measure of its central angle. The expression measure AB is read as the measure of arc AB. The measure of the entire circle is 360 degrees. This is important. You can't forget that all the way around a circle there's 360 degrees. The measure of a major arc is the difference between 360 degrees and the measure of the related minor arc. The measure of a semicircle is 180 degrees. So down here at the bottom, you'll notice, even right here, the measure of ADB, arc ADB, you'll notice that they put 3 letters. So is that a major or minor arc? Answer that question to yourself. And so as you look, that is clearly a major arc. And so we're thinking from here, we're kind of making our way around ADB, and we're making our way there. So we've got ADB. If you know that this part is, 50 degrees, then you can pretty much quickly figure out that in order to find the rest of the circle, you would say the whole thing is 360 degrees, and your minor arc is 50 degrees, so you're left with a total of 310 degrees for your major arc. And so over here, this entire arc over here has a measure of 310 degrees. So it's a simple subtraction problem to find the measure of a major arc. So you've got major arc, minor arc, and that's what we're talking about. All right, let's look at some examples. So we'll zoom this out a little bit and we'll hit this example, feel like we understand it. So it's really helpful. You'll notice that they're using a lot of symbol notation, and as we read this, you want to make sure you understand what that symbol notation means. And so it says find the measure of each arc of circle P, where RT is a diameter. So first of all, you need to find RT. And so we're looking at RT is right here. I haven't developed my coordination with this particular stylus, so if you'll forgive my wonky lines, I'm going to get there eventually. So it says right here, find the measure of each arc. So we've got RS. RS, first of all, question for you, is that major or minor based on its name? Okay, it's minor because you only have 2 letters that are given. So that mark RS, and I will just squiggle this switching between this and a highlighter is very difficult for me right now. Again, I'll learn all the tricks eventually as I practice more of this, but we've got RS here. And so hopefully your eyes draw right to that RS. And so the question is, how long is it? What's the measure of it? Well, of course, I remind you that the rule up here was the measure of a minor arc, which is what we said, is equal to the central angle, the measure of the central angle. So RS must be what? 110 degrees. Because, again, it's equal to the same measurement as the angle that's pushing or pointing towards it. All right, so let's look at number B, letter B. All right, letter B says RTS or arc RTS. Is that major or is it minor? Hopefully you're saying major, and so major arc, and so our eyes should be going RTS. That looks like it's going to go, notice the wording matters, so you're going to go all the way around like this with your eyes. Well, again, it's a simple subtraction problem. If we have 110 right here and there are 360 total, we come over here and we say 360, and we subtract what? 110. And so we get, over here we've got 0, we've got a 5, we got a 2, and so we got 250 degrees. And so the measure of this is 250 degrees. This particular one over here was 110. And then we come over to RST. So let's clean this up a little bit and we'll hit a little bit more of the examples. Alright, so we're looking at arc RST. RST, notice I start here when I start drawing it. RST is going to start at R, go past S, and it's going to terminate at T. And so I'm looking at kind of this semicircle. The question you need to ask yourself is, how many degrees does a semicircle have? And you should be saying 180. So again, this is a simple subtraction problem, but we're only concerned with half the circle. And so you should be saying, all right, 180 minus 110, this will give me 70 degrees. And so my final answer for this portion is 70 degrees, but it's not asking for the minor arc. That would be arc TS or ST. Let me fix that. You can write that either way. That's 70 degrees. But the question was, what is RST? And that RST is a semicircle. And so we could have been done faster. I led you down a wrong road. But that's all it's asking, simply going through it. So we learned a couple things. When they say RTS, that is not the same thing as RST. RTS means go this way all the way to the S. RST means go this way all the way to the T. And so there's a lot going on here that we want to make sure we're careful about. All right, so down here, just a little bit further, oh, actually, before I go further, I'd like to say you could also use all your old knowledge. You're fully aware that these make a straight angle, these two angles here, 110 and the one I just marked. And so because they form a linear pair, they are supplementary, and so 110 from 180 gives you 70 degrees. I simply add the two and I get 180. Again, this doesn't get any very creative. It's stuff we've done in the past. All right, let's look at a note. Two arcs of the same circle. Let's zoom this in and focus on what we need to. Two arcs of the same circle are adjacent if they have a common endpoint. All right. And again, you'll have to forgive my art skills here, but well, let's use this one up here. This will be better. So we have several arcs that can be seen in this circle, but we're looking for something called an adjacent arc. So let's go to TS and let's talk about RS. Well, obviously they both have an S in common, but if you start looking at this, we're talking about this particular arc and we're talking about this particular arc. Notice they have a common point of S, and therefore they are adjacent arcs. All right. You'll notice, though, that RS and TR are not. I say that. Hold on, let me make sure I'm thinking one-sidedly, and so you'll see what I was saying. I was saying RS is not, so if I start going this way, and TR, well, they actually are adjacent arcs, and you could probably see that by the sheer fact that they share R in common. So before I jump to any conclusions, but that's what we mean by adjacent arcs. Two arcs that touch each other and are very close. And so that's the definition of an adjacent arc. Two arcs of the same circle are adjacent if they have a common endpoint. All right, let's get a new postulate. Remember, postulates are rules, and so they do not have to be proven. It says this. I'm turning my page over to 650, and so here they are. Postulate 23 says, arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the two arcs. All right, so they give us on the side there a circle. Let's see how I do here, drawing my own circle. It was okay. And so I've got a point here that is A. I've got a point over here that is B. And I've got a point over here that is C. Well, again, what they're saying is that if I wanted to find arc ABC, which is essentially the entire circle, you could say that arc ABC is essentially the addition of arc AB. Okay, let me draw that. Arc AB is all of this plus the measure of arc, not angle, that's different notation, arc BC. Okay, and so there we go. And so that's going to give me ABC. Okay, I said this is the entire circle. That's not true. This is going to go all the way from here to C. It terminates at C. It doesn't go back to A. And so that's all they're saying. So if you wanted to find the arc addition postulate, you could do that. So that I'm clear, I'll come back over here and write that out so you see it. Going back up to example 1 that they drew for us, I've got the arc RST. Okay, that's the entire arc at the bottom. Well, it's equal to what two arcs that are added together? You should be saying RS plus TS. So let's put our arc notation on it. Notice this major is the sum of two minors. Okay, and so that's all we're saying. So here's the rule. Basically, if you want to know how big an arc is and you have two of them, you add them together. All right. Example 2. All right, so it gives us an opportunity to try some of that. Example 2 says, this is a survey. A survey says, a recent survey asked teenagers if they would rather meet a famous musician, athlete, actor, inventor, or other person. The results are shown in the circle graph. And so as we look at the circle graph, the results are shown here. Find the indicated arc measures. And so we see that there's a large amount that want to meet a famous musician, pretty much athletes. I'd be curious if this is true of you. Would you rather meet an inventor? Looks like we don't care about inventors. We just want to use their stuff. I don't know what that means, but I don't know, streamers. I don't know. Anyway, so you've got arc AC. Again, looking at those A, B, C, D, do you know if they're major or minor? You should. AC, and letter A there is a minor, whereas the other three are majors. All right, so let's find the indicated arc measures. Let's take letter A. It says arc AC. Your eyes should automatically go there. Okay, arc AC. Well, AC is going to be the sum of AB and BC. Okay, and so when we look at the two, obviously it didn't give us both of those. So letter A, the measure of arc AC is equal to, let's see, 29 plus 108. Your final answer for that particular one is 137 degrees. All right, let's look at B. All right, letter B says find the measure of ACD, or arc ACD. So ACD is all the way from A all the way to D. And so you're going to take the sum of 29, 108, 83, and you're going to add all three of those together. Once you do that, you will get a final answer of 220 degrees. All right, let's look at letter C. I'm going to give you an opportunity to take, let me clean this up so you can see it better. Always feel free. Whoa, I did something cool. You always have the opportunity to do this, and you can look at your book. Of course, we're on page 650, so you can look and see it clearer if I write all over it. But letter C, you got ADC. So where do we start? Where do we end? So again, my thinking was, I start going this way, but it says ADC. So we really ought to go counterclockwise to A, from A to D, then end at C. All right, so we're going to add 79, 61, 79, 61, and 83. And so we've got the measure of arc ADC is equal to those three numbers, 79 plus 61 plus 83. And so we've got 223. Now, if you notice your book, you'll notice that they did not do this the same way. You'll notice that they subtracted it from 360. They said, why add 3 when I could just add 2? If you take 108 plus 29, excuse me, throwing things, but if you take 108 plus 29, so we got 108 and we add 29 to it, that equals 137. That 137 that we get, we come back over here, we take that 137. If we wanted to find the whole thing, if this portion over here is 137, we could also just subtract it from 360 to find the other. So let me erase all this. If just the left side is 137, this portion of the pie chart, then the other part's 360 minus 137, and so that's how they got their 223, pulling that up. So they did 360 minus that, okay, that 137, and their final answer would have been 223. And so that's how they did that. That's what they did. All right, let's look at letter D. And again, being educated means we got to be able to do it both ways. All right, letter D. It says find the measure of EBD. We'll do it their way this time. E, B, and D. All right, so EBD says we start at E, we go towards B, and then we end at D. So we're getting all of this, EBD. Okay, so we're essentially just doing the whole circle but 61 degrees. So 360 minus 61, and we will have our final answer of 299, excuse me, 299 degrees. Now, obviously, you could add up all the numbers that were in that black squiggly line, 108, 83, 29, 79, and you get 299, but they're just trying to show you the fastest way that they can come up with. All right. Let's move on, and let's take a moment and do Gotta Practice 1 through 6 real quickly together. Page 650. I'll give you just a moment if you pause the video just for 1 or 2 minutes. We'll get back to this, but I'm going to work through each of these problems, or at least give you the answers to them. All right, so at this point you have either gone through this pretty quickly or you're done. And so here's number 1. Number 1 has a circle, and I'm not going to draw it. Well, I am actually. So here's your circle, and you've got several markings, and so here's your center. You've got a line that's coming this way. You've got another one that's coming this way. 80 degrees here. A segment over here. We don't know the bottom part. This particular portion's a little bit smaller at 60 degrees. And then at the very top, we got 120 degrees. Okay? Now, a couple of things are at play here. Number 1, it says, I need letters. And so this top left one's T. This particular one is S. This one down here at the right is R, and then it's Q at the top right. And so letter 1, or number 1 says TQ. Now let me read the instructions. Identify the given arc as a major arc, a minor arc, or semicircle. All right, so essentially I can just look through this and say, all right, all minor arcs have how many letters? And you should be saying 2. So this arc TQ can be measured from T to Q. That's just 120 degrees. That's a simple read. Number 2, it says QRT. So my first thought is major arc, but let's see what it looks like. QRT. QRT is going to go all the way from Q to R to T. Now the problem is we don't know this bottom angle. All right, so you should be thinking, because these two are vertical, that this is also 120 degrees. Now add them up and make sure it adds up to 360. So you've got 120 plus 80 is 200. 200 plus 120 is 120 plus that's 200. That's 320. 360. So I'm missing something. I got excited. And so that looked like it was right. It's not. And so let me pull out this calculator. Can we not make that assumption? So we have 120, I don't know if you can see this calculator or not, but I'm using one, plus 80, plus 60. And so what you're left with is 260. 260. So 260 from 360 gives you that negative 100. And so I can't assume that. My first thought was, yeah, they're vertical, but then I break the rule that everything seems to be 100 degrees, or sorry, that everything is 360. So this is not necessarily a vertical angle. So that was an assumption. It was not true. As I look at this, realize the primary rule is the measure of the central angles in a circle must add to 360 degrees. And so, again, it could have been smoother, but again, if I don't make that assumption, you now know don't make that mistake. So your thought was, oh, they're vertical, they look the same. They're not. So QRT, now that we know the angles, we've got Q, R, and T. So that's going to be 60 plus 80. It's going to be 140. Yes, and plus 100 degrees is 240 degrees. Number three says, oh, by the way, that is a major arc. 240, it's greater than 180 degrees. Number 3 says we want to find the arc TQR. Now that we have all our measurements and we've done all the thinking, it's a little bit faster. TQR, so we're going to start at the top, make our way around. So 120 plus 60 is 180. Now, my drawing doesn't look it, but how do you classify 180 degrees? Okay, so we'll go with this one. So this one's a minor arc. I'm doing a little m for that. This is a major arc, capital M. This is a semicircle. Okay, and then number 4, here we go. So number 4 says QS. QS. So here's QS. It says Q to S is 100 plus 60. Very simple, just 160. Number 5. Number 5 is TS. TS. So here we go. TS arc. So TS is simply just 80 degrees. And then number 6. Number 6 is RST. Major or minor, you should be thinking either a semicircle or major, can't be a minor. RST, we're starting at R. Starting at R, and we're working our way to S, then to T, and so we've got 180 total. What do we classify that as? And so you should be saying semicircle. Obviously, this is a minor axis, or minor arc, I'm sorry, and then this over here is also a minor arc. And so that's my notation I'm going to use for that. So simple stuff that they're asking us to do. All right, let's look over here at the next section. At the bottom of 650, it says 2 arcs are congruent arcs if, I'm looking at our time, we've got just a little bit of time left. 2 arcs are congruent. No, that's not what it says. 2 circles are congruent if they have the same radius. So 2 circles are congruent if they have the same radius. So I recall telling you at one point a circle by definition is a central point, a radius that's been drawn, and anything that forms around that that's equidistant from that center point. So we form a circle. So 2 circles are congruent or equal if they have the same radius. That makes sense. 2 arcs then are congruent if they have the same measure. So 2 conditions here, same measure, and they are arcs of the same circle or of congruent circles, because if they're congruent circles, they might as well be the same. So they have 2 conditions, same measure and arcs of the same circle. Same measure, same circle, or congruent. So this will be kind of picky, but you'll see what I'm saying in just a moment. All right, take a moment, write it down, maybe pause it. Once everyone's got it, let's move on. All right, here's example 3. Example 3 says, identify congruent arcs. All right, so again, review. 2 circles are congruent if they have the same radius. 2 arcs are congruent if they have the same measure, and they're arcs of the same circle or congruent circles. So down here, tell whether the red arcs are congruent. Explain why or why not. All right, notice in this particular one, letter A, we're looking at CD, and we're looking at EF. Are they congruent? I would say, and you probably would agree with me, that arc CD is congruent to arc EF, and the reason being is they're in the same circle and their measures are equal. Precisely, they are 80 degrees in each one. So again, there's that rule. The arcs are the same measure and they're in the same circle. All right, let's look at this next one. All right, look at this one. So what's the measure of these two? Obviously, they're both 90 degrees. All right, but in order to be a congruent arc, and the reason I knew it was 90 was this right angle box, okay? In order to be a congruent box, they also have to be in the same circle or congruent circles. These circles are not congruent because their radii are different. So if you draw this particular radius, it's not going to be the same as this particular radius. And so we're going all the way to this one. And so the radii are different lengths. So from there, we're looking at letter C. So obviously for this one, letter B, before I move on, RS and TU have the same measure but are not congruent. So you can say that they are not congruent because they don't have by that definition up here, you've got two arcs or congruent arcs if they have the same measure. They do, and they're in the same circle or congruent circles, and they're not in congruent circles. So they fail the test. All right, move on to the third example. So look at each one. You'll notice that these particular ones are 95 degrees. 95 degrees. And then once we look at this particular one, you'll notice this little hash mark. That says what? Okay. And also, what is this TV line called? You should be saying radius. Well, since it's a radius, that means they're equal. These two circles are congruent circles. And when you have two arcs that are equal measure and in equal circles, you have congruent arcs. So we can say with certainty that arc UV is congruent to arc YZ. Okay? Got a cool symbol there. Arc YZ. All right. Let's do, just for a moment, 651, got to practice 7 and 8. All right. So if you look at the two circles, you've got two, and I won't draw them. I don't want to scare you. So page 651, tell whether the red arcs are congruent, explain why or why not. So here's number 7. I'll give you a second to look at it. You can pause the video and you can ask somebody and they'll tell you in just a moment. All right, someone should have said, first of all, the measure of the two angles, or the two arcs, the measures are 145 and 145. And they are, in fact, congruent because they have both conditions. They have the same measure and they're on congruent circles. The congruent circles because the radii are equal. Let's look at number 8. You'll notice they don't have hash marks this time. They actually measure the radii. You've got one that's 5, one is 4. So one circle's bigger than the other. And so obviously your brain should say, all right, so MN is clearly 120 degrees, PQ is 120 degrees. Are they congruent? Your answer should say no. They have the same measure, but they are not in equal or congruent circles because their radii are different. And so that's what you should be looking at. All right. That concludes this particular lesson, and so I will give you your homework now. You can pause the video, take a moment to write this down, and when you get your opportunity to do so, you can, once you have it written down, you're good with everything, you are dismissed at the bell. Thank you.